In Lesson 6.1, Part A, you'll learn how to graph quadratic functions. How can income from a rock concert be maximized? Rock music managers handle publicity and other business issues for the artists they manage. One group's manager has found that based on past concerts, the predicted income for a performance is P of x equals negative 50x squared plus 4,000x minus 7,500, where x is the price per ticket in dollars. The graph of this quadratic function is shown at the right. At first, the income increases as the price per ticket increases, but as the price continues to increase, the income declines. People won't pay that much. A quadratic function is described by the equation in the following form. F of x equals a x squared plus bx plus c, where the quadratic term has the x squared, so it has an a as the coefficient. The linear term is just plain x, coefficient's b, and the constant term has no variable. The graph of any quadratic function is called a parabola. One way to graph a quadratic function is to graph the ordered pairs that satisfy the function. Graph f of x equals x squared plus 3x minus 1 by making a table of values. First, choose integer values for x. Then evaluate the function for each x value. Then we'll graph the resulting coordinate pairs and connect the points with a smooth curve. You guys are blessed to have calculators with a table feature. Back in the day, we would substitute negative 3 in for x. Negative 3 times negative 3 is 9, plus 3 times negative 3 is negative 9, so we're up to 0. So then I get negative 1. So my ordered pair that I'll plot is negative 3, negative 1. Negative 2 times negative 2 is 4, plus negative 6 is negative 2, minus 1 is negative 3. And negative 1 times negative 1 is 1, plus negative 3 is negative 2, minus 1 is negative 3 again, which is something we're not used to seeing in a linear equation, but a quadratic equation will repeat itself. 0 times 0 is 0, plus 3 times 0 is 0. 0 plus 0 is 0, minus 1 is negative 1. And if we substitute 1 in, 1 times 1 is 1, plus 3 times 1 is 4, minus 1 is 3. To use the table feature on your multi-view calculator, first you're going to push the button that says Table, and then you're going to type x squared plus 3x minus, and be sure to use the minus sign, not the negative, it will know the difference, minus 1, and hit enter. The next screen asks for a start value, so this time we will hit the negative button. So I'm going to start at negative 3 and then hit enter, step by 1, hit enter, and we want to leave it at auto, which has it calculate the values for us. You can switch it to ask if you want to put in your own values. And this little box here says OK, and then we're going to hit enter. And when I hit enter, I see if x is negative 3, y is negative 1, which is what we had when we did it by hand with the table. Negative 2, negative 3, negative 1, negative 3. Okay, the table on the multi-view calculator is really small. It's a $15 calculator. What can you expect? So next I'm going to push that down arrow, and it'll scroll down and give me the rest of the values. This is as many values as I'd like to see. Now I can plot the points that I found. Negative 3 was at negative 1. Negative 2, negative 3, negative 1 is also at negative 3, so the minimum is somewhere in between there. 0 is at negative 1, and then 1 is back up to 3. And connect them with a nice smooth curve. It should be symmetric. All parabolas have an axis of symmetry. If you were to fold a parabola along its axis of symmetry, the portions of the parabola on either side of the line would match. The point at which the axis of symmetry intersects the parabola is called the vertex. The y-intercept of the quadratic function, the equation of the axis of symmetry, and the x-coordinate of the vertex are related to the equation of the function as shown below. Consider the graph of y equals ax squared plus bx plus c, where a does not equal 0. The y-intercept is when x equals 0, so a times 0 squared plus b times 0 plus c is just c. The equation of the axis of symmetry is x equals negative b over 2a, and the x-coordinate of the vertex is also negative b over 2a. Consider the quadratic function f of x equals 2 minus 4x plus x squared. Find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. The first thing we're going to want to do is write that equation in descending order, and I did switch out f of x for y. The coefficient of x squared is 1, the coefficient of x is negative 4, and the constant is 2. To find the y-intercept, all I have to know is, what is c? c is 2. The next two questions have the same answer. We're going to substitute in negative b, so negative 4 is just going to be 4, over 2 times a, so I get 4 divided by 2 is 2. So the equation of the axis of symmetry and the x-coordinate are both going to be 2. For an equation, I need to write out x equals 2, and the x-coordinate is just going to be 2. So those are 3 answers for one question. Next, they ask us to make a table of values that includes the vertex. So I'd like to go a couple numbers less than 2. So if I start at 0, that'd be nice. 0 plus 2 is 2. And then we've got 1 minus 4 is negative 3, plus 2 is negative 1. Four minus 8 is negative 4, plus 2 is negative 2. 9 minus 12 is negative 3, plus 2 is negative 1 again. And 16 minus 16 is 0, plus 2 is 2, so we've got 4, 2. Plot the points. Plot the points and connect them with a nice smooth curve, and they also drew in the axis of symmetry. You can see it's the same distance to that same point on either side. So again, when we graph, we're going to start off graphing the vertex and the y-intercept, and then graph points from your table, connecting them with a smooth curve. As a check, if you draw in the axis of symmetry as a dashed line, it should be symmetric about that line. Before we had handy-dandy calculators with a table feature, we would do this technique a lot, use symmetry to help find other points of the graph of the parabola. So once I know I'm 2 units to the right and what my y value is, I can use that to go 2 units to the left. Once I know my y value 3 units to the right, I can use it to go 3 units to the left. The key points we're looking for when we graph parabolas are the y-intercept, the vertex, and the axis of symmetry, which is found by using the equation x equals negative b over 2a.